Hello everyone, today I'm going to solve one problems related to groundwater chapter. So here I have taken one questions. You can see a 30 centimeter diameter well completely penetrates a confined aquifer of a permeability 45 meter per day. Okay, so the length of the strainer is 20 meter. Under steady state of pumping, the drawdown at well was found to be 3 meter and the radius of influence was 300 meter, and we have to calculate the discharge. Okay, so now I am going to solve these questions. So from the questions already I got some informations. So I have the RW. So RW means I have to divide it my diameter divided by 2. So I have 30 meter diameter, so I will divide it by 2. I will get 15 centimeter. So if I want to convert this 15 centimeter, I have to make it meter, so I will get 0.15 meter. Simple. Then I will get my another information. I already have the permeability. So my permeability is K, right? So K equal 45 meter per day. Okay, so I have my permeability in meter per day, but I want to make it meter per second. So 45 times day 60 60 24. If I do, I will get 5.208 times 10 power negative 4. This is meter per second. All right, so now I will read the length of the strainer is 20 meter. That's mean the B equal 20 meter here. All right, now under steady state, so my condition is steady state. The drawdown at the well was found to be 3 meter. So my SW equal 3 meter. Okay, so now the radius of influence. So I have the radius of influence, which is called RW, so which is 300. All right, so all the informations that available in my questions I already list down in my paper. All right, so now once I have the K and I have the B, so easily I will get the transmissibility. So T equal KB. So I will write down my K value. So my K value is 5.208 multiplied 10 power negative 4 meter per second times B. My B is 20 meter. All right, so I will get this meter, and meter will be meter square per second. Then 5.2, if I multiply, it will going to be 0.010416. So 0 I can write in this way also, 10.416 times 10 power negative 3 meter square per second. So I already get the transmissibility T. Okay, so now let me take one page. All right, now I have to find out the discharge Q. Okay, so we have the formula 2 pi TSW divided ln R over RW. Okay, so I have 3.1416 times I have the transmissibility 10.416 times 10 power negative 3 times I have also SW. So SW equal 3 meter. Okay, because this 3 meter comes from here. You see, the well was found 3 meter. Okay, now ln my R radius of influence. So I have 300, and Rw I already got from the diameter 0.15. If I calculate, I will get 0.02583 meter cube per second. All right, my exercise 3 finish because I already find out the discharge. So now I'm going to solve the example 4. Okay, in the example 4, for the well in the previous example, calculate the discharge. So if the well diameter is 45 centimeter, okay, so now they change only the well diameter. Okay, so we have to find out the well diameter. So if you see, I can do these questions. So B example 4 I will get. So B equal, so I will change the diameter, so and all the value will remain. So Rw equal 45 centimeter, so I divided by 2. If I do divide it, 45 over 2, I will get 22.5 centimeter. So if I do 25 centimeter 100, 22.5 over 100, I will get 0.225 meter. All right, so if I want to get the discharge with the different diameter, but all the values remain the same, so I just change this part. Okay, I just change this part. So Q equal, I have the formula 2 pi t is W divided ln R influence radius and Rw. So I will get 2 times 3.1416 times 10.416 times 10 power negative 3 times SW equal 3 divided ln radius, influence radius will be same, then I only will change the diameter. So my diameter in this case, if I do 0.225, and if I calculate it, so let me calculate 2.3.1416 times 10.416 times 10 power negative 3, 10 power negative 3, then I will times with 3 divided ln. Okay, so I will get 3000 and 0.225. Okay, so I will get 0.0272. Let me erase this R because I haven't write the R value. So this Q in meter cube per second. So this is my solution for this discharge if I change the diameter for these questions. All right, so now I'm going to solve another questions. Question B, if the drawdown is increased to 4.5 meter and all other data remain unchanged as example 3. So in here I have to change the drawdown. Okay, 3.0, so it will become 4. So in this case, what I'm going to do, I will change it and it will be same. Okay, question C, I will write Q equal 2 pi TW is W divided ln R over RW. So 2 times 3.1416 times T, I have the transmissibility. So 10.416 times 10 power negative 3 times. Okay, so in this case, I have to only change the SW because the questions told us to find out the increased value. Okay, 4.5. So I will just write the 4.5 here. 4.5 divided ln the same value because they told us to remain all those values same. So R is 300 because this is the same radius of influence, and Rw is I have 0.15. Okay, because they told us to do as example 1, right? Example 3 that I just already finished. So I will, if I do calculations, I will get 0.0387 meter cube per second. All right, thank you so much.